Hello and welcome to our webinar on inscribed angles. This webinar is to be watched before Tuesday 4/12, and so we're going to talk about inscribed angles today, and we'll talk about what they mean. But this is something that we learned the other day, and basically you can go ahead and work on this, pause it, and try it on your own, or I'm just going to work through it. But the first thing that we learned is that if we have a diameter that meets a chord at a 90-degree angle, that it not only cuts the chord into two equal pieces, it cuts its arcs into two equal pieces. So I can say that 7x equals 3x plus 24. And doing that, then I can say that just solving it algebraically, I have minus 3x from both sides. I end up with 4x equals 24. And then if I divide by 4 on both sides, x will come out to equal 6. So if x is 6 and I want to find the measure of arc rs, and they say 7x is rs, the measure of it, that means that rs, the arc itself, the measure of that arc is going to equal 7 times 6, which is 42 degrees. And that's really all they're asking for on this one. So now we have a whole bunch of definitions that we need to go through. And first of all, it talks about what an inscribed angle is. And an inscribed angle is an angle whose vertex is on the circle. So that's this over here. This point, the vertex is right there. I'll make it a little big in red so you can see it. That's the vertex of the angle. And this is different than a central angle. The central angle goes to the center. And so this one, the intercepted arc out here, is the blue, and basically we have some theorems that are going along with it. So we have an inscribed angle. If you remember, a central angle goes to the center, like down here at ACB, and a central angle is the same as the arc itself. That's when it goes halfway across the circle. So for this first theorem, if an angle is inscribed in a circle, and it ends up being the measure of the angle is half the intercepted arc, is what we end up with. So AB. So if we find the measure of arc AB, it would equal a half. If we were talking about angle, the measure of angle ACB, which is the central angle, it is equal to the arc AB. That's just a reminder of central angles. And so then if we have two inscribed angles, and this is kind of hard to see, I probably, if I would have been writing this, I would have done angle ACB, which is this angle right here, ACB, and angle looks like BDA, this angle down here, since they have the same endpoints. So here's angle B down to D up to A, they have the same endpoints, and then the other one would be ACB, they're intercepting this same arc, this arc out here, then they have the same angle measure, so they're congruent. So we could put angle D here if you want to, but basically it says if you have two angles that intercept the same arc, then the angles are the same measurement, which is what we know. So those are our two theorems. Make sure you pause it and copy them down. So then we have some couple questions. This is example 1, and in example 1 they're giving us the circle, and they're saying, well, what's the measure of angle T? Well, first thing I look at is what kind of angle T is, and I notice that angle T is an intercepted angle, is an inscribed angle, which goes back to what we just talked about in the previous slide, that let's go back and look real quick. The inscribed angle is half the measure of the arc. So if I know the arc is 48 degrees, then half of that arc would be the measure of angle T. So half of 48, so 48 divided by 2 is 24. That's the measure of angle T. Well, if you notice, they want to know what the measure of the arc is this time, and since the angle is half the measure of the arc, we would have to double this angle to get the measure of the arc, and so we have 100 degrees for that one. And so if I get rid of this little shade down here, you can see here's all the work. You should pause it if you want. You can write it down, and basically you could figure out Oh, they're asking for QR, sorry. I thought it was QT. Well, QT is 100 degrees, which is this part right here. QR is what's left over. And so if this is 100 degrees, I got to be able to read my questions here. If QT is 100 degrees, then if I subtract from 180, since we have a semicircle here, that has to be 80 degrees because the half of a circle is 180 degrees. So helps to read the questions correctly in order to get these right. So that's QR is 80 degrees. I read what I wanted to read. Sorry about that. Okay, so then this one is asking us to find the measure of RS, the arc RS, which is this one. I'll mark it in green. They want and they want the measure of that arc right there, and the angle STR. So that angle right there. So what do you notice about these two angles, STR and RUS? Well, RUS intercepts the same arc, so that would mean that the angle STR is equal to RUS, meaning they're both 31 degrees. Well, if we know the measure of the angle, we have to double it to get the arc, so SR, arc SR, is 62 degrees. 62 degrees. So let's remove this and see what it looks like down here. And you can see they said they were equal to each other, so therefore they gave them in different order, but that's basically the way it works out. So pause it if you need to, copy it down, and rewind it if you need to. So we're moving along here. So on to example 3. It says name the pair of congruent angles in the figure. Now this one's always a tough one for people. I have these angles here. I have angles inside that I've got to figure out. So I know that JM, that the angle JLM, I'm just going to write this down, angle JLM is equal to the angle JKM, because they're intercepting the same arc, JKM, and that's just knowing that they intercept the same arc of JM. I also know that this angle over here, KJL, intercept the same arc as KML. So I'm just going to write that down. So we have KJL has to be the same as angle KJL. It would be LMK. We'll do that, LMK. And so now I got to look for these guys over here. Let's see. It looks like that JKM is equal to KJL. That doesn't work. That doesn't match this one here, so A is out. And then we've got JLM is congruent to KJL. That's not true. That doesn't match my first line there, so I can cross that one out. And so JKM must be equal to JLM. That one matches. That's a good one. That's a star for that one. Supposed to be a star, but well, you get the point. And then we have KJL is congruent to KML, which is the same as this one, so C is the correct answer for this one, but we'll check JLM. JLM needs to be congruent to K. Yep, that one doesn't work because the J and the K need to match up, so that one's out, so C is the correct answer for this one. And basically it was just a matter of knowing the properties that if you have the same intercepted arc by two inscribed angles, then the angles are congruent. Moving on to example 4. This one says find the measure of the red arc or angle. This time it's a red angle. And the first thing that I notice is that the angle itself is an inscribed angle. So I know that it is half the measure of the intercepted arc, and so that has to be 45 degrees. And it's just remembering my theorems, and that's what you guys, that's what's going to be the struggle of this, is that you guys need to remember these theorems. You know them, you got to learn them. I mean, it's just what it is. So there it is. Moving on to the next one, find the measure of the red arc or angle. Well, in this case, we're asked for an arc. And when we're asked for an arc, I know that TUV is an inscribed angle. So if I double that, I end up with the intercepted arc. And so the arc has to be 76 degrees. And over here, this time they want the measure of the angle. And when you have the measure of the angle, it is this one is intercepting. You'll notice that the red angle ZXW is intercepting the same arc as the other angle of ZYW, and this is what we just went through, so those would have to be the same, and so they're 72 degrees for that one. So, pause these if you need to and copy down the work, but this is the ideas of what's going on.